Our next step is to figure out a way to study this. So obviously, we can't just study all 4,000 cities. This would be a very uneconomical way to do it. So instead, we've decided to create a sample instead of studying the entire city in the universe. So we settled on this 200 city sample. And this 200 city sample divides the world into regions, country size categories, and city size categories. And that allowed us to weight the sample towards small countries with few cities, so that we have more countries represented. And we tested our sample, and we found that it's accurate to a 95% confidence interval, which means that we can safely generalize the things that we learned here at MES about these 200 cities to the universe of 4,000 cities as a whole. So this is now known as the United Nations sample. And it provides the first ever statistically significant way of studying all of the cities on Earth at the same time. And this is a sample that we're monitoring in all 4 phases of this project. So in the first phase, let's see, the Atlas of Urban Expansion, we have a team at the University of Connecticut that is collecting satellite images for 1990, 2000, and 2010 for all 200 cities. And they're analyzing these images into built-up areas, areas that aren't built up, and water. They then combine these with population information that we gather from the Columbia Institute of Earth Sciences to create something that we call the Atlas of Urban Expansion. And this is a representative page from the Atlas of Urban Expansion. So the Atlas tells us a number of things. It tells us the total area of the city. It tells us the total population of the city in 3 time periods. It also tells us how fragmented the city is growing. So how much open space is there between the built-up parcels of the city? It tells us about dispersion. Are people moving further out, or are they developing closer in? It tells us about the city's tendency towards circularity, the city's tendency toward wholeness. And it also shows us, very importantly, the comparison of the city to its regional peers and to the global average. And this atlas is being produced in 2015. It'll be released this year by the Lincoln Institute of Land Policy. And there's an older version of this that's available for free download along with the GIS files and the data tables in Excel form. So please use this information. So what did we learn from all this research? Well, for starters, we learned the tidbit that I mentioned earlier, which is that population densities are falling around 2% a year in all cities. So I'm going to take a pause to talk about an important topic, one of my personal favorites, which is administrative area density versus built-up area density. So do you remember the map of China's administrative area density? This area that was 11 times larger than the built-up area of the city? Density is generally calculated quite simply. It's the total number of people divided by the total amount of land. Okay, fine. But the total number of people in an area is pretty easy to calculate. But the total number of land is something that you can change quite arbitrarily. So, for example, if you calculate Beijing's population density based on that administrative area, it's about 6 people per hectare, which is unrealistically low if you know anything about Beijing or cities. But if you calculate it based on its built-up area, which is to say the share of land that is actually occupied by buildings and structures, it's a much more normal 200 persons per hectare, about the same as Manhattan. So the simplifying assumption that we make here is that human beings live in places where there are buildings. When we talk about density at the urbanization project, we're talking about this built-up area density. And this chart shows the differences in built-up area density by region in 1990 and 2000. So what we see here is that globally, population density was around 140 persons per hectare in 1990, and they have since fallen to around 120 persons per hectare. Now, you might think, oh no, density's falling. But actually, this is a good thing. Densities fall primarily for one reason. Densities fall because people are getting wealthier. When incomes rise, people consume more of everything. They consume more transportation, they consume more food, they also consume more land. However, if densities become too low, as you can see here in the end in the land-rich developed countries, which is the United States, Canada, Australia, and New Zealand, it becomes impossible to sustain public transportation, and there are environmental consequences as people begin using cars. In addition to this information about density, which is maybe a little bit thick, we also learned where the growth in cities is taking place around the world. As you can see here, historically most of the growth in cities has taken place in the land-rich developed countries, the United States, Canada, and Australia, and in Europe and Japan. But between 2010 and 2050, almost all of the growth will occur in sub-Saharan Africa, right? So you see here, the share of growth is moving to sub-Saharan Africa, it's moving to the Indian subcontinent, and it's moving to China. So when we're planning for urban expansion, when we're thinking about regions where we should be planning for urban expansion, it's clear that these are the places where we should concentrate our efforts. As a subset of this study, we also collected historical information on density for about 30 cities, stretching back to around 1800. So for the periods after 1980, we used the Landsat imagery that you've seen earlier. For the periods before 1980, we had to rely either on aerial photographs or on historical maps that showed the built-up area. And this is a very unique study because previously no one had examined the historical population densities in cities. Nobody knew what's happened to population densities over time. We knew that densities were falling, but we had to decide, is this something that we need to be worried about? Is this a long-term trend? Is this part of a cycle? So we conducted this study. So this is an example of a map that shows built-up area. It's the Colton map of New York from 1836. The shaded area at the tip of the island represents the built-up area. And indeed, lucky for us, it has been a common map-making convention to include built-up areas on maps as a shaded zone. It was this information that we used in studying our historical samples of cities, and we used it to create maps like this. So this is a map that shows the growth in Paris from 1800 at the very center all the way to the year 2000. And what we see here when we combine this with population information is that the population of Paris increased 20-fold, but the total area increased 200-fold, in line with our expectations about falling density. So we learned that in general, these show the density curves for 4 cities from 1800 to 2025. So what we learned is that in general, population densities rose in the 19th century and fell in the 20th century as transportation became more available. They now appear to have leveled out in our 30-city sample. However, the 30-city sample is biased toward large global cities because in order to use historical maps as a basis of a study, there have to be the maps that we were taken from, and here you see the growth in Paris. Now remember how small the historical center was. And we see here mass suburbanization between 1955 and 1979 and into the 1990s. And then after 1990, Paris starts to fill in somewhat. So you can see this extremely rapid growth that took place after cheap transportation became available. This very rapid spatial growth. So now let's take a look at Mumbai. This is Mumbai in 1814. We're going to Mumbai in 1849. You can see, still concentrated. 1865, 1888, okay, 1909 we start to see a little growth, 1931. Now we know all this time the population of Mumbai is increasing, right? Every year it's getting higher. Finally, in the 1950s, we start to see Mumbai expand north into the suburbs. We start to see Navi Mumbai grow in 1990. 2000. So, the thing to note about this animation, we did not see the dramatic expansion in city area that we saw when we were watching the animation of Paris. And what that means is that the growth in Mumbai hasn't happened yet. This growth is coming. So right now is a very unique moment. It's a rare moment because we know that the big explosion in growth has not occurred. old Mumbai has not decongested, which means we can actually engage in planning for the expansion that's going to come. So I am actually going to pick up on this general topic of monitoring global urban expansion. Remember I said it's a 4-phase project. So far we've talked about phase 1, which is the Atlas of Urban Expansion. Phase 2, A and B, which were phase A is here, and B going on in Valencia, studying the 200-city sample here on the quality of urban expansion, and the 30-city historical sample in Valencia. Again, so we can say something now, we'll be able to say something about how much cities are growing, and also something about the quality of that growth. Now, this leaves us with 2 phases, phase 3 and phase 4, of course. So phase 3 actually touches on something that is pretty important to me personally, and I think important to a lot of us who work on urban issues, which is the idea of equity. So phase 3 asks, is housing affordable to the great majority of people in cities? And what are the factors that affect the affordability of housing? So to learn this, we first have to gather information on the regulations and rules that govern housing, which we're planning to get from city officials and developers in our 200-city sample. And then we have to get information on land and home prices in the expansion areas of these cities. And then we'll be able to say, how are the planning and policies in these cities impacting the ability of people who are moving to the city from the country, people who are being born in the city? How are these plans and policies impacting the quality of their life? So how are we going to do this? We have 200 cities. We need information on hundreds of variables for each city. So let me tell you, I live in New York. And one of the wonderful things about living in New York and about working at New York University is that we have actually been able to find people from each of the 200 cities in the sample who we can hire to call these cities on the telephone. So we're recruiting these people to undertake a telephone survey of these places. And we're piloting this right now at NYU with students from Kenya, China, India, Mexico, and the United States. So this is a wonderful thing about this. The second part of this, which is to get the information about land and home prices, is a little more tricky. Because if you want to learn about high-end real estate, this is easy. You can get on the internet and you can learn about high-end real estate for almost every city on the planet. But if you want to learn about real estate for the bottom quarter of people, which is what we're interested in, people who have trouble affording housing, you really have to be on the ground. We call it the se vende problem, because in Latin American countries, the way real estate for people who are in the bottom quintile is advertised is by these signs in the expansion areas that say se vende, which just means for sale. So what we need to do is figure out a way to get information on these parcels. Some of them are informal, some of them are formal, almost none of them are advertised online or in the paper. In order to do this, it's quite complicated. It will involve hiring hundreds of people in countries all around the world and tasking them all with collecting consistent, accurate, statistically representative information in a way that's never been done before. So we have some ideas about how to do this. We're open to more, but the main idea right now is to hire taxi drivers and journalists. And in each of these 200 cities, to create a team of a taxi driver and a journalist. Why a taxi driver and a journalist, you might ask? Well, for one thing, taxi drivers and journalists don't cost very much money, and we don't have a lot of money to do this project. For another thing, taxi drivers have cars, and they know how to get to places. So if you say to a taxi driver, where is the edge of Mumbai? A taxi driver can take you to the edge of Mumbai. In fact, from where we are right now, they know that it's right over there, right? It's on the other side of the field. Journalists are people who are skilled in obtaining difficult information. So they know how to talk to people, they know how to learn about these things. So what we want to do is create these teams to get the information that is needed. So this is still in the planning phase, but we're very optimistic about the results. And it's a tremendous opportunity because it will be the first time ever that a global land and house price survey has been conducted, which means it will be the first time ever that we can actually make a definitive statement about how affordable housing is in cities around the world. So the great thing about this is because we're using the same 200 city sample, we can correlate this with the information from the regulation survey and also with the information that we're producing here at the observatory, and we can make conclusive statements about the impact of planning before people occupy the land, and also about the impact of urban policies on the affordability of land and housing. This is something that we're hoping to do. In our final phase, phase 4, we want to translate all of this information that we're collecting into growth projections for the entire universe of 4,000 cities. All 4,000 cities with populations greater than 100,000. We want to be able to say how these cities will grow in the next 40 years. We want to know how much they're going to grow, and we're also building a model that will indicate to us where they're likely to grow. So why does this matter? Well, what this means is we can make a convincing case for laying out networks of arterial roads and public open space in advance of development. We will be able to say conclusively, with these policy interventions, you will have better results. Right now is a unique time to be affecting the urban agenda. One thing that Pritika mentioned is my university, New York University, has a partnership with the United Nations Human Settlements Program, UN Habitat. And it's through this partnership that we're undertaking this research. So why does this matter? UN Habitat organizes itself around a series of conferences called the Habitat Conferences. And they happen every 20 years. So the first one was in 1976. The most recent one was in 1996. The next one is happening in 2016. And this is the Habitat 3 conference. Our work, according to Executive Director Huang Close, will be the jewel in the crown of Habitat 3. It represents a major leap forward in how to study urban policies and programs. So, if we conduct this research successfully, and if we can successfully advocate for planning urban expansion in a systematic way, we will be able to disseminate that information through the most important conference on cities in 20 years, at a time when we know cities are growing more rapidly than ever before. And just to be totally clear, Manuel said it, I'd like to repeat it. The most difficult component of this work is being done right here at MES at the India Urban Expansion Observatory. So this is a great achievement. And it's also the most important component because this provides information for the first time ever on the quality of these expansion areas. And when we think about expansion areas, let's keep in mind that we're talking about areas that people generally don't go to unless they live there. These are areas that are often neglected by planners, and there are also areas that are most in need of proper planning. So, to conclude, the work being done here at MES is changing the way that we will study and work in cities for the next 20 years. This is a huge achievement, and I am so grateful to be here today. Thank you.